Okay, section 3.2. Again, I'm going to just leave my notes up here. You can pause it if you want to. This basically summarizes the information from the textbook. So our slope, it's the only real formula we have to remember. You don't really have to remember it, but you will. After you do a few of these, it'll stick with you. Like we'll get to a point where we'll talk about slope, point slope form. You don't need to know that. You can do everything with slope intercept form, and you get slope intercept form from using the slope equation. So M always stands for slope. Don't ask why they decide to do that. It's a rate of change. It's rise over run. It's slope. They call it M equals rise over run, y2 minus y1, x2 minus x1. Always in this order. Y always on top, x always on bottom. Okay, so example 2 says find the slope of a line through these 2 points. Here's your y2, x2, y1, x1. I'm going backward. I'm taking y2 minus y1, x2 minus x1. Doesn't matter which point you start with. You could make this x2, y2, and this x1, y1. It doesn't matter. You'll get the same slope. So remember that. Okay, so you work through it and you get that. I'll do a couple in a minute. Example 3 is talking parallel perpendicular. Don't let that throw you off. Just know parallel means the slope will be the same. Now perpendicular means the slope will be the negative inverse. So the same slope here, negative inverse there. I can get more into that with one. We'll see. I don't have one to do here, but you can ask me questions if you don't understand parallel perpendicular. We'll do a couple of them later. So slopes and rate of change, average speed, all those examples I just worked out here. Again, you can pause it if you need to. I'm not going to work through them all. And that was it for 3.2. So let me do a couple examples real quick. Like I said, I don't think there was a perpendicular and parallel in section 3.2. They just introduce it. So number 12 I chose. Number 12 says, here's our 2 points, find the slope of the line. And I think they want us to graph it, then plot each pairs, draw a line, indicate rise and run. We can do all that stuff. Remember, make one of these this basically you could say this is point 1 and this is point 2. Or you could switch those. The key is keeping our x1, y1 and x2, y2 with the right one. So we take our y2 to find slope. Our y2 is 2. We subtract y1. In this case, our y1 is a negative, so we're going to end up adding. And then we take our x2 minus our x1. So when we take 2 minus a negative 3, we're actually adding 2 plus 3. And 5 minus 2 is 3. Nice thing here is, again, we just leave it. Yeah, it might look goofy that that's an improper fraction, but that's how we're going to leave it. They want us to end up plotting this. I'm just going to do it real fast. We would say when x is 2, so I'm going to 1, 2, 3, 4, 5. When x is 2, y is negative 3. 1, 2, 3. There's that point. When x is 5, y is 2. 1, 2. There's that point. We go here, and then when they start talking rise over run, they're talking rise. How far does it go up? Over run. How far over? So there's the rise. How far up? And then here's the run. How far over? We can talk about that. You can ask questions. I can explain it further, but you never really have to know rise over run. Some people prefer rise over run and just counting once they get a point. My mind worked better with just solving all the equations and plotting points. I never worried about rise over run. I plotted my points, found the slope, whatever it was, I just graphed the line. So again, some people like rise over run, other people don't. It doesn't really matter. There won't be a lot regarding rise over. I might ask you, if I ask you to indicate it's only one time on the entire test. Other than that, I want you to show that you can graph this stuff and you understand how to find slope. That's the key. It's finding slope and then slope intercept form as well. Let me do number 21 because these give people a little bit of difficulty sometimes. They are leaving one out. A3 is our first point, and our second point is 2, 6. And we can't solve unless we know something else, and we do. We know the slope is -1. If I wrote, yep, I wrote them all down right. And okay, so what this means is I'm going to do the long route. I'm going to write everything out. I know that my slope is y2 minus y1 over x2 minus x1. Well, they give us m. When you have a formula, this is a formula. When you have a formula, just start plugging in everything you know. So I know that my m is actually -1. So m equals becomes -1 equals. And then my y2, I just typically I choose to make that 0.1 and that 0.2. It just makes sense to me. Once they're on a graph, doesn't matter which one's your first and second point. So y2 is here. That's 6. I'm going to subtract y1. There's my y1, 6 minus 3. Then x2 is here. I'm going to subtract my x1, and in this case, it's a. Yep, we don't know it, but that's fine. I have one variable. When I have one variable, I can solve for it. So what happens, I'll put it down here. I have -1 equals 6 minus 3 is 3 over 2 minus a. Now, I need to get rid of this quantity because I need to move it up so I can solve for a. So to do that, I'm multiplying both sides by that quantity. Whatever's in your denominator, it doesn't matter how big it is. You multiply the entire equation by it, and it goes away. So 2 minus a divides into 2 minus a. That's going to leave me with 3 over here. And then I just have to work this piece. 2 minus a times a -1. That's easy enough. I am simply, and I'm going to leave it in this order because it doesn't really matter. I'm simply negating it. Times -1. I just changed the signs. -2 plus a equals 3. Now I just solve for a. A equals 5. That's all I think they wanted. Yeah, so solve for the indicated variable. So in number 21 through 28, all you're doing is solving for the variable by using your slope equation. Set your equation up, put everything in that you know, and you'll have one, here's my cat, you'll have one variable that you have to solve for. Okay, that's it for 3.2. I don't really have anything else. Well, just know, like let's take number 12, we solved, the slope was 5/3. Any line parallel to that will have a slope of 5/3. Any line perpendicular to that, we have a negative inverse. So -3/5. Parallel, they're the same. Perpendicular, negative inverse. So you either put it over 1 if it's a whole number, or you just flip them if it's a fraction. Okay, that was 3.2. Fun times.